Hello everyone, and welcome back to another video. So this is an update video for progress on the e-powered GTX 780 Ti Matrix Platinum. And as far as the e-power is concerned, this is basically now in a final state. There is more work to do. Specifically, it needs a lot of capacitors, and I still need to mod the 8 pins so that I don't have to plug them in. But yeah, so basically the e-power is hooked up now in and that's what I want to talk about a bit. So you've already seen the connection of the ground plate. As far as the ground plate is concerned, I was a bit worried that maybe the connection card side wasn't all that good. Because so the ground plate, even when using the switch nodes on this, isn't all that big, because I didn't. So if we look at the 680, I talked about how, like, I don't really know if you can see it, but like down there, I put two uninsulated cables to short all the switch nodes to the ground layers of the card, so that my switch nodes would be extra ground. On this card, I didn't really have enough space to do that, because the ground and switch node layers are a lot thinner and like wider. So there wasn't really a place to conveniently put a cable and then still have like a flat place to hook the plate up to. So what I did instead is just kind of put the plate like down on top of both of them, so that it would both touch the ground and switch node layers. Yeah, that's basically what I did. And I was kind of worried that maybe the connections aren't that good. I do think now that the connections are pretty good, because what I did is I just took a 150 watt iron and pressed down on the connection and then slowly dragged it along. And I was a bit worried that maybe this wouldn't be strong enough to like melt the solder between the card and the plate. But after hooking up the V-core plate, I don't know if you can. Yeah, it's probably not. Well, you might be able to see it. You can see how solder comes out the side under the plate. So since I did the exact same thing for the ground plate, pretty sure that there's a good connection there. Yeah. So V-core plate, basically exact same thing. It is a bit shorter than the ground plate. I could have actually made it like there's another like half centimeter here, and then there's another also like slightly over half centimeter here that I could have made it longer. But I don't really think at this point it would do much, because this is still a very, very good V-core plate. Because again, just like the ground plate, it is rather short and very wide, which is exactly what you want for your power plane. You want your power plane to have a low resistance. That means you want it to be very, very wide and very short. Then for memory, I originally only had this one plate on the top. As you can see, it is rather thin and pretty long, which is not what you want. And then I also added this plate to the back, which... So this plate is a bit special. This is literally just leftover plate that I just had left over after cutting the memory and V-core plate. And basically what this is it was too wide. It was actually twice as wide as it looks like now, and I actually just used pliers to like fold this in on itself, so you can kind of see how this is thicker, because this is actually two layers folded on top of each other, and then soldered on so that it like would fit the power plane here, because there's like a ground pad right there for the former capacitors. Yeah. So this plate is not just twice as wide, but also twice as thick. So this one's basically 4 times as good as the plate that I had before for carrying current, which means that the memory now also should have a pretty good connection. Yeah. So the main problem just being that, especially the memory, has literally no bulk capacitance on the PCB. The only bulk capacitance it has is on the E-power. And, well, this means that the card doesn't really do clock memory that well. It depends on what benchmark you run. In this state, it runs pretty much every benchmark at stock clocks. So, like, it runs TimeSpy, it runs 3D Mark 11, it runs Unigine Tropics. It does not run Firestrike for some reason, though I think that's more a problem with my Windows install, because like I've used that Windows install to overclock memory, and it's also been through several different GPUs without DDUing. So because Firestrike either just crashes instantly or artifacts pretty heavily when other tests don't do that. I think 3D... well, no, actually. Yeah, no. Yeah, other tests straight up don't artifact at stock clocks if I set the correct voltages. Yeah. Then for the core, it still has these mortalized ceramics here. But as for the CAN types, yeah. So I also removed those, which kind of was a mistake. I think in hindsight, I would have rather left those on and then have had a slightly smaller vCore section to solder to. As you can see, I didn't need all the scratched up vCore section I had, so I would have been fine just scratching a smaller area and leaving the capacitors on. Yeah, that's basically the one change I would make for future e-powers. And yeah. So I tried to put the capacitors back into the holes that I got them out of, but either my technique or my soldering equipment just wasn't up to the task. So after failing for like a couple times, I decided to scratch the back of the card as well, because there's a very convenient vCore and ground layer where the vCore VRM is. And then I also scratched the switch nodes, because since the ground plate's touching both the switch nodes and the ground layer in the front, these other switch node layers are of course also ground. So I also have a vCore ground and then vMem ground places here where I could put more capacitors. I did run out of capacitors and I couldn't find the slightly bigger tip for my 75 watt iron. So these capacitors were actually soldered on with my 150 watt, which is a very bad idea because that iron is so strong, like literally whatever you touch, it melts instantly. And probably also destroys capacitors really quickly because it just heats them up so much. Like, I think these capacitors don't really do anything, which I'm probably going to remove them again at some point. Because these are the same capacitors I pulled off the card, and for all I know, these have been through many years of probably stock fan curve operation. They've been through the vCore VRM having a major meltdown, strong enough to melt this hole into the PCB and an even worse hole in on the front of the card. And then they've been through me using my extremely strong 150 watt iron to desolder them. Again, that iron is strong enough to literally like destroy power planes when I touch them for long enough. So these and then like soldered on again using that same iron. Like, I think these don't really do anything anymore. I think these capacitors are just dead by now. Yeah. But I did kind of run out of good capacitors, and I still haven't found... Like, I'm pretty sure the extra tip is in the packaging for my 75 watt iron. I just need to find the packaging. And I think it's in a drawer that's behind my bed, so I have to move my bed to get to that drawer. So that's quite annoying, because I put stuff there that I knew I wouldn't need in a long time. But I think I left the tip in there, and I do need that tip. Because the small tip like even with preheat, the small tip is not strong enough to solder anything to the card here, because first of all, it's a big PCB. I'm soldering directly to VCore and ground power planes, which are the biggest power planes on the card. And then also that's exactly the area where the big copper plates for the E-power are connected to. So basically this is the worst place on the card to have a weak tip. So yeah. So I need to locate my stronger tip for the slightly weaker iron. And I need to find new good capacitors. And then I'll be able to cap mod this. And for the memory, I do want to populate these empty spots with multi-layer ceramics and then put like 3 capacitors over them. And I think these I also want to cover with more capacitors. Because like I think even the stock output fitter, like this is not even all the capacitors I pulled. I think these are 2 or 3 capacitors less than I originally pulled from the VCore VRM. Even with that output filter, I think the output filter is not all that great. Like, it's just a bunch of multi-layer ceramics and a few can types. That's it. 780 Ti's pull quite a lot of current. Like, not as bad as 980 Ti's, but they are still close. And I kind of want a bigger, like, I think I actually would have wanted 1200 microfarad can types, and then a row of SP caps, and then a bigger row of multi-layer ceramics. I think that's what I would have wanted for this. But yeah, sadly Asus didn't provide that. At least they provided a very convenient way of adding extra capacitors to this. So I'm probably going to end up pulling these off again at some point. And then I can put a row of capacitors here, row of capacitors here. The memory sadly doesn't have the ground plate, so I can only put like 2 caps here for the memory. But then, yeah, like again, populate this with the multi-layer ceramics and also put capacitors over this. Yeah, and I think that's basically, I don't think I can really do any more than that. I could probably stack multi-layer ceramics behind the memory chips. I'm not gonna stack anything behind the core because of my mounting solutions. Because so I did some testing with mounting hardware, and basically the best mounts I was able to achieve used like metal back plates that moved the mounting pressure from the 4 mounting holes more towards the middle of the core. So I can't put anything here because, well, like all the pressure is in this area and it will just destroy any capacitor I solder there, or exert very uneven pressure onto the core. So I'm not cap running anything behind the core, which I don't think it would do much, actually. I don't think it would do much. So, yeah. As for overclocking, it doesn't seem to be that great right now, mainly because of that capacitor problem. Like, the capacitors on the E-power are probably helping, because, I mean, they are helping as much as they can, because well, for the memory there could be a much better connection, but for the core, I think there can't really be a better connection. This is already about the shortest they can be, because, you know, like, there's these extra 8 pins here. So I can't really get the E-power any closer. And, like, okay, apart from that, like, maybe 1 centimeter extra, the power planes are also as wide as they go. Like, as far as I'm concerned, the power hookup, at least for VCore, for memory it's also pretty good, like, don't get me wrong, but for VCore I think this is basically as good as it gets. So these capacitors are probably helping as much as they can. I still don't know how much they can help, because while this is probably just as good as an in-PCB power plane, they are still, you know, like, if you fold this flat, the capacitors would sit about like here-ish on the PCB. That's pretty far away from the place where they used to be, and adding extra distance, even if that's through a very efficient power plane, is still always bad. Yeah, so I mean, of course, e-powers need output filtering, but like capacitors on here will always be less efficient than capacitors directly on the board. That's just kind of thing that you just kind of need to keep in mind. Yeah. Oh, then, and one other reason why it not might overclock well is because I haven't modded the 8 pins yet. I still need to plug those in, of course, to not get the please plug in power connectors message. And my power supply only has 4 plugs, so I need to leave the center one on the e-power empty. Now the e-power runs like that, but of course it's not recommended, because like if you end up drawing a lot of power, you're gonna overload the 2 outer ones, and this will lead to worse input voltage regulation. Now there is a substantial input filter here, but it probably won't hurt to actually connect this third one. That might also be a reason. Because actually, like, I mean, is this all the input filtering it has? Yeah, this is all the input filtering it has. So that it doesn't have any multi-layer ceramic input. Well, it has a couple here. But, yeah. Because I think I've seen on like 16900 XTs, like putting multi-layer ceramics and like SP caps onto that input filter, like helped. First with Colvine and second of all with overclocking. Though the 16900 XT has like an awful input filter. It has like basically nothing. It had basically this, and that's it. It doesn't have any of this. But yeah, not having this connected might also be a reason why like basically I'm making the voltage regulator's life a bit harder than it has to be. And yeah. So yeah, I just kind of wanted to give this update because I've run out of capacitors and I need to locate that ion tip. I think for now I'm mostly done with doing things. Like the thing I can still do now is like mod these to not be plugged in. But as far as putting more capacitors on this goes, I think I'm not going to be able to do that rather soon. So I wanted to give this update on how the card's doing, and yeah. And yeah, like, I mean, my design goals are still being followed. Like, it is a low power, like a low profile e-power. Like, it fits within 2 slots. So theoretically this is 4-way capable. Yeah, this is literally 4-way capable. Yeah, and like it looks nice, you know, like it's basically what I wanted. I didn't want like having just kind of weird wires going places. The solder joints, well, they could be a bit more photogenic, but I'll take it. Like, I'm gonna put capacitors here anyway that are gonna cover it a bit. Mainly I blame my flux, because my flux just leaves this yellow and black burnt residue everywhere. That's just, yeah, I need to buy better flux. But yeah, so it is using copper plates. Like, you know, if you look at my very first e-power with copper plates, this is kind of a big upgrade. You know? So it's a rather big improvement. So it uses copper plates. It looks really proper. It is very practical to work with. The memory plate hooks up nicely. The capacitors are also not like one thing I wanted is I didn't want the capacitors to like go up like this. I wanted to be them like flat. So first off, so that I can put the card down. Like, it still wobbles a little bit, of course, but, like, yeah. Like, basically, how the capacitors are soldered on, they're not putting all the weight on the legs. The cap part, or like the can part of the capacitor is actually also contacting the PCB and putting some of the stress when I put it down that way. So that's kind of what I wanted. And yeah, so my design goal is still being achieved here, with like this being a very nicely made and yeah, at this point reliable e-power. Like it runs stock clocks reliably. It's just that the overclocking is not that great yet, probably because of the input filter. Yeah. And one thing that I haven't talked about yet is voltage drop. So I did put on a different water block for a test yesterday, so I could access the capacitors behind the core to measure my voltage drop under load. And under load, vCore is dropping 70 millivolts and memory is dropping 50. When I go off of the values that it displays here, I didn't measure the actual output voltage on the e-power. I just took whatever it was displaying here, comparing what I measured behind the core or on the furthest memory chip. So I set 1.22 here. I was getting 1.15 here. For the memory, 1.55 here, and I get 1.5 here. Now I have to say my multimeter seems to be running rather low on battery, because like when I measure voltage, it jumps around like a lot to unrealistic values. Like it's sometimes it jumps to like 0.8 volts on vCore or like 1.8 volts, which obviously is not true. Voltage isn't jumping around like that. So my multimeter battery is kind of running low, which, you know, might make the results less accurate, but it pretty consistently showed those voltages in those places when I measured them. So I was kind of hoping to have a little less voltage drop, and the minimums are probably also not that great, because again it needs capacitors. But thinking about it, I think 70 millivolts on core is not that bad actually. I think I remember seeing like a reference GTX 480 drop 100 millivolts, like from the onboard VRM to behind the core. I think I remember it being 100 millivolts. I'm not entirely sure if it was 100. It might have been less. But like I remember measuring it, and I remember it being a very high number. And admittedly, I haven't measured many cards stock VRM voltage drop. So yeah, but like 70 millivolts is a bit higher than I hoped. But then again, this is hooked up basically as well as it goes. Like with the power planes that are present on the card, I can't really do this any better. And like stacking another copper plate on top of this is not really gonna make it better, because the power bottleneck here is the connection point, not the actual copper piece itself. And putting another plate on top of this just uses the same connection point. It doesn't make the connection point any wider. So, yeah. And I think that would be it. Yeah. So that's the update on the e-powered 780 Ti Matrix Platinum. I'm mostly satisfied with how it's going. I'm kinda disappointed that the overclocking doesn't work yet. But I mean, that's what I get for removing all the capacitors. Yeah, that's like the one mistake I made with this, is removing the capacitors. I should have left those on, because I still could have put capacitors here and still could have put stuff on the back. But as far as it goes, I think I'm just unable to put these back into the holes where they were. So I guess that's not happening. Which is a little bit sad, but I think it should be fine. But yeah. So thank you for watching. Hope you enjoyed, and until next time, goodbye.